Hello everyone, myself Devashish Das, Assistant Professor of Electronics Communication Engineering Department of Greater Kolkata College of Engineering and Management. In this video, we are going to study about the different topics of analog electronics and its applications, how the analog electronics apply in our different fields of electronics. In this video we are going to study about it, different circuits and its part we are explaining one by one in this topic. Analog Electronics 1. This course is mainly for diploma students of electronics and telecommunication engineering of third semester. The paper code is PTCE AE1S3. Welcome to another video lecture of my session. In this session, we will discuss the formation and behavior of a PN junction diode. That means how the diode is behave. In this section, we will discuss mostly on that topic. So in this session we will cover up the following topics: introduction to PN junction diode biasing, formation of forward biasing of PN junction diode, formation of reverse bias of a PN junction diode, the band diagram of PN junction diode in forward and reverse bias, the depletion layer modification in forward and reverse bias. So we'll discuss these topics one by one. So let us begin. First come the PN junction biasing. That means first come the biasing. So what is biasing? A battery is connected to a diode. This is the most important thing. We have to apply voltage to a diode. So when we apply voltage, so diode is a two-terminal device. One is P side, another is N side. So there are two types of biasing, and the battery has two polarity. One is positive terminal and the negative terminal. So combination of this we can create two types of biasing. One is called the forward biasing or the forward bias mode, when the positive terminal is connected to the P region and the negative terminal is connected towards the N region of the diode. Another biasing is called the reverse biasing. In this reverse biasing, the negative terminal is connected to P region and the positive terminal is connected towards the N region of the diode. So let us discuss these two biasing one by one. First come the forward biasing. In case of forward biasing of a PN junction diode, the forces of the majority charges carrier to move across the junction, decreasing the width of the depletion region. That means the majority carriers of the P side, that means the holes, and the majority carrier of the N side, that means the electrons of the N region, they are move across the junction freely, and the depletion region width of the layer is decreased. Once the junction is crossed, the number of electrons and the number of holes will recombine. For each hole in the P section that combine with an electrons from the N section, a covalent bond breaks and the electron is liberated. That means it becomes free, which enters the positive terminals, thus creating a electron and hole pair. Current in the N region is carried by the electrons, the current in the P region carried by the holes. So this phenomena happens in the forward biasing of a PN junction. So here we can see a picture of the forward biasing of a PN junction. Resistance is there present to just limit the current, because in case of forward bias, if we do not apply any resistance, there will be a huge current flow in the diode, through the diode, so the diode get damaged. So we have to apply some resistance to protect the diode from the excess current flow. So first thing, if we neglect this resistance, the P section of the diode is connected towards the positive terminal of the battery, and in the other hand, the N section or the N terminal of the diode is connected towards the negative terminal of the battery with the help of one switch. This is a switch. When the switch is closed and the current flow happens. So this is the forward biasing. In case of forward biasing, the current flow happens. How it's happened? In case of P section or the P side, the holes are the majority carrier, and in the N side, the electrons are the majority carrier. So this is the positive terminal of the battery, which is consist of positive charge, and the holes are also positive charge. So the positive charge and positive charge get repelled, and these holes are pushed towards the N section of the diode or the N terminal of the diode. And when the holes are get entered in the N terminal, there are lots of electrons and they are recombined. So in this way, the holes are easily come towards the N section and become recombined. On the other hand, the majority carrier of the electron in the N section is easily repelled with the negative terminal of the battery, as the negative terminal is the negative and the electron are also negative. So they are repelled towards the P terminal of the diode, or the P section of the diode, and the electrons are get recombined with the holes. So there is no barriers, or there are no interrupter media which allowed to current flow. In this way, the current flow happens in case of forward bias of a diode, PN junction diode. So it is the schematic diagram of a PN junction, you can see, and it is the block diagram representation of the PN junction diode. In this way, in case of forward bias, the current flow, this current flow happens with the help of electron and hole together. So for the N section, the current flow happens due to electron, and in the P section, the current flow happens due to the hole. But the combination of these two, electron and hole, the total current flow happens. So in this way, the forward bias current flow happens. Now we see, take the band diagram of this forward bias. We can just see this curvature of the band bending of this is the depletion width. The bending of band is the width of the depletion region. We can see when the forward bias is happen, this depletion region vanishes and there is no depletion region, and the band is, there is the band bending which is very little, so the electron flow can happen very easily. So there is almost zero resistance to flow the electrons from the P section, from the N section to P section. The electron flow happen from the P side to N side. We see, take this electron flow happens from the N side to P side. So the electrons flow happen from N side to P side. So in this way, the electron flow happens and the conventional current flow happens in the opposite side of the, from the P section to N section. the current flow happens from the p side to n side, but the electron flow happens from n side to p side. So here you can see the electron is flowing from the inside to p side, so there is a no barrier and the electron can flow from the inside to p side very easily. So this is the representation of band diagram, representation of a forward bias. Now comes the reverse bias. If the positive terminal of the battery is connected towards the N terminal, N-type semiconductor, and the negative terminal of the battery is connected to the P-type semiconductor, then the reverse bias happens. The free electrons and the free holes are attracted back towards the battery, hence the back from the depletion layer. Hence the depletion layer grows. Thus a reverse bias of PN junction does not conduct current. This is the most important thing which you have to keep in mind, that in case of reverse bias, the depletion region width is grow and there is no current occur in the reverse bias. Only the minority carrier cross the junction continues a very low reverse saturation current. Thus current is of the order of microampere. So we take the example of the reverse bias. It is the diagram of a reverse bias where the N terminal is connected towards the positive terminal of the battery and the P terminal or the P-type semiconductor is connected towards the negative terminal of the battery. And here we can see there is a pull in the both the side. In the electrons are get pulled towards the positive terminal of the battery and the hole are get pulled towards the negative side of the battery. So there is no flow of current. We'll take another example. In the inside the electrons are get pulled and we can see in the P side the holes are get attracted towards the negative terminal of the battery. If we plot this to potential in the depletion region, in case of inside the electrons are the majority carrier but the holes are the minority carrier, so there is a little bit holes present in the depletion region. And in case of P side the electrons are the minority carrier, so there are presence of electrons in the P side. So interesting thing is that there is a case of forward bias in the depletion region with the help of the minority carriers. This is the most important thing. There is a forward bias of minority carriers in the reverse condition of the diode, reverse bias condition of the diode. So this minority carrier take part in the conduction of reverse saturation current or the reverse leakage current in the reverse bias of the diode. So in case of the reverse bias of the diode, there is a flow of electron which is minority carrier in the P side and the flow of holes which are the minority carrier in the N side, and that current flow is occurred and produce a reverse leakage current. So in this way the reverse leakage current occurs and a reverse leakage current is present in the reverse bias of a diode for a practical diode. In case of ideal diode there is no reverse leakage current, but in case of practical diode there is a reverse leakage current which is very small in order of microampere. And we have take another example of the reverse bias. In this example, we'll discuss the depletion region of the diode. So when a reverse bias applied in the diode, the depletion first, this is the original depletion region or the original barrier which was present in the diode, but when we apply the reverse bias, the depletion region get increase with the help of reverse potential. More the potential, more the depletion region or the depletion width get increase. This is the most important thing. More the reverse voltage, more the depletion region width. So we just take the band diagram of this whole thing. So the first picture represents the when there is no biasing, that means when we do not apply any voltages. The band diagram look like this. There is a band bending, and it is for the p-type material, and this section is for n-type material. So there is a depletion region is there. When we apply the forward bias, this depletion region is reduced and the current flow occurs. In case of the reverse bias, the depletion region grow more and the band bending will grow more, and there is a no flow of current, but there is a reverse leakage current is there. So with the help of this picture, you can see the comparison between the three things. First, the zero biasing, that means when there is no bias, the forward bias and the reverse bias. So this is a very important thing. Now we take the animation of the whole thing and we just make a summary of it.
The process of fabricating a p-n junction begins with an n-type or p-type doped semiconductor, into which the opposite type of impurity is introduced. To understand how this structure works and what physical processes take place in it, a didactic model is used. The model consists of a p semiconductor perfectly matched to an n semiconductor. The p semiconductor has a much higher hole concentration than the n semiconductor. Therefore, holes from the p region will diffuse into the n region. Similarly, electrons from the n region will diffuse into the p region. The diffusion of electrons and holes creates a region depleted of free charge particles, leaving behind the ionized impurities from which these charge particles come. Thus, a region of positive ionized impurities and a region of negative ionized impurities appear in the p-n junction. This special distribution of charges creates an electric field. The electric potential associated with these fields acts as a barrier that prevents the displacement of the electrons and holes. Equilibrium is reached when the diffusion current equals the drift current. The potential barrier is an obstacle for the diffusion current in the device. It is possible to reduce the height of this potential barrier by the application of an external voltage. This increases the electric current. By applying an external voltage from a battery, the height of the potential barrier in the junction is modified. If a positive voltage drop is applied between the p and n regions, the barrier height is reduced. A reduced barrier cannot prevent electrons and holes from diffusing across the structure. An electric current appears in the junction due to the diffusion mechanism. Under these conditions, the p-n junction is said to operate under a forward bias. If the voltage is reversed and becomes greater in the N than the P region, the barrier height increases, preventing the electron and hole diffusion. The electric current is then negligible. In conclusion, the p-n junction can only conduct in a single direction, giving rise to a current which increases very rapidly when the potential barrier is significantly lowered.
Thank you for watching. If you have any queries, you can contact to me. The contact number is given. The same number can be used as WhatsApp number. If you have any queries or doubt, you can call me or WhatsApp me to this number. Thank you very much.